Would we predict that an NH4CN solution to be acidic or basic? NH4 plus is related to the weak base NH3, and CN minus is related to the weak acid HCN, so we can't tell by inspection. What related information is found in the reference tables? We can very quickly find the Kb for ammonia, because ammonia is a very common weak base. That is the equilibrium constant for ammonia to gain a proton. We can also very quickly find the Ka for hydrocyanic acid, because that's a very common weak acid. And that would be for HCN to lose a proton. But we have NH4 plus, not NH3. And NH4 plus would tend to lose a proton. And so we need its Ka, which is not in the tables. So we need to calculate it. We know that the Ka for the ammonium ion times the Kb for ammonia, which is right here, 1.8 times 10 to the negative fifth, that product is 1 times 10 to the negative 14th. So if we take 1 times 10 to the negative 14th divided by 1.8 times 10 to the negative fifth, we get this number here, 5.6 times 10 to the negative 10th, which I call the conjugatized Ka. Conjugatized is kind of a fun word to say. You might want to practice that. That's the conjugatized Ka for ammonium. We need to do something similar with the anion. And we have the cyanide ion, not hydrocyanic acid. And cyanide ion would gain a proton. So we need its Kb. We need to calculate the conjugatized Kb for cyanide ion. And again, we do it the same way. If we look on the right side of the screen here, near the top, I'm circling with my laser pointer the Ka for hydrocyanic acid. That number times this one at the bottom equal 1 times 10 to the negative 14th. Good. Well, we have the Ka for the cation, and we have the Kb for the anion, and now we just compare those two. And we see very clearly that Kb is much larger. It's some 100,000 times larger. Therefore, we would predict a basic solution. Kb would win, so the pH would be greater than 7.